Hello and welcome to Physics with Amol sir. So this video is for class 10th and we are going to continue with the chapter light. Now we are starting after quite a long break. I hope that you have utilized this time for self-study. Okay. Before you are starting with this video, please ensure that you have gone through the previous material and you have revised the topics. Otherwise, if you are starting right now, you might get confused. Okay. So far in this chapter, we have talked about spherical mirrors and we spoke about how image is formed by the spherical mirrors and we saw some numericals as well. And previously we saw about the lenses, concave lens and convex lens, and we talked about the rules for refraction by these lenses. Okay, so make sure that you remember the rules. Today we are going to talk about image formation by lenses. Okay, so let's start. First we will see the image formation by a convex lens. So first let us draw a convex lens. This is how we are going to draw our convex lens, and this will be our principal axis. I am sure you remember this. Now for a convex lens we are going to have two focal points. One will be over here, that we'll call as f1, other will be on the right hand side, that we'll call as f2. Twice of f1 we'll call as 2f1, twice of f2 we'll call as 2f2. I'm sure you remember all these. If not, please go through the previous videos. Now we are going to see few cases for image formation by this convex lens. Okay. First case is when the object is placed at infinity. Now if you remember, object placed at infinity means the object is very much farther away than the focus. Okay, it should be quite at a large distance from focus. For example, if our focal length is 5 centimeters, okay, and if the object is placed at, let us say, 200 centimeters, you can call that as infinity, no problem. Okay, infinity does not mean a very large distance. It simply means farther than the focal length. Okay, so there is some object that is placed at infinity. Let us say this is our object. Now because the object is very far away, okay, all the rays that are coming from the object are going to be parallel to the principal axis. If you remember, same rule was followed when we were talking about mirrors. Okay, if an object is at infinity, all rays will consider parallel to the principal axis. So one ray comes parallel to the principal axis. After refraction, it will pass from f2. I hope you remember the rule. So that ray will go from f2. This is the first ray. Second ray will come from the bottom, that will also pass from f2. Okay, a ray that is coming towards the optical center, that will pass without any deviation. So you can see all the three rays, they are meeting at f2. So if object is at infinity, image will be formed at f2. Remember, okay, this is the diagram from the textbook, right? So if any object is placed at infinity, image is formed at the focus. What kind of image is it? It is a real image. Why real? You can obtain it on a screen. So the image that will be formed will be a real image. Then it is going to be highly diminished. It will be a point-sized image. Fine. And another thing, it is going to be inverted. Remember, a convex lens will form an inverted image at the focus. Okay, I hope that is understood. Now let us see the second case. Second case, when the object is placed beyond 2f1. So now from infinity we have brought our object just near the 2f1 value. Okay. If object is placed at 2f1, let us see the image formation. First ray we will draw parallel to the principal axis. So a ray which is parallel to the principal axis, after refraction will pass from f2 like this. Okay, that is the first ray. Second ray you can consider going towards the optical center. So ray which goes towards the optical center will pass by without any deviation. Okay, so you can see they are meeting over here, and this is where we will get our inverted image. Okay, so if object is placed beyond 2f1, image is formed between f2 and 2f2. Okay, what kind of image it is? It is a real image. It is an inverted image, and the size is diminished. Okay, here is the diagram from the textbook. Okay, you can also consider a ray that is passing from F1 and after a refraction it will pass parallel to the principal axis, or you can consider a ray going through the optical center. Both cases are fine. So this is second case. Now let us see the third case. Third case, when object is placed on 2F1. Okay, so if the object is placed on 2F1, again first ray we will draw parallel to the principal axis. A ray which is parallel to the principal axis will obviously pass from the focus, that is F2. Okay, another ray you can draw once again going through the optical center. So ray which is going through the optical center, and both the rays will meet here and we will see image being formed on 2F2. Okay, so if object is placed on 2F1, we get image also on 2F2. Okay, I think this will remind you of the case of the concave mirror. In concave mirror, if object is placed on C, you get the image also on C. A similar kind of a case where if object is placed on 2F1, image is obtained on 2F2. Then what kind of image it is? It is a real image, it is an inverted image, and the size of the image is the same as that of the object. Okay, here is the diagram from the textbook. Okay, four cases when object is between F1 and 2F1. Again, as usual, the first ray will draw parallel to the principal axis. After refraction, it will pass through F2. So it will go like this. Okay. Next ray we are going to draw going through the optical center. That ray, when it goes through the optical center, we see that they intersect over here and we get image beyond 2F2. Okay, so if object is placed between F1 and 2F1, image is formed beyond 2F2. What kind of image it is? It is a real image, it is an inverted image, and now the size is going to get magnified. Here is the diagram from the textbook. Next case, object is placed at F1. So how do we make the ray diagram? Once again, first ray parallel to the principal axis. After refraction, it will go through F2. Whenever you are making ray diagrams, please remember to make the arrows to show the direction. Second ray will draw going through the optical center. Now you will notice that both these rays are parallel to each other. Therefore, the image is going to be formed at infinity. Okay, remember. So if object is placed at F1, the image is formed on infinity. Again, this image is going to be real in nature. Okay, it is going to be inverted and it is going to be highly magnified. Okay, that is the case for the object placed at focus. This is the diagram from the textbook. Next case we are going to see when object is placed between optical center and F1. Now this case you will see is little different than the others. Let us see how. First ray, as usual, we will make parallel to the principal axis and it will pass from focus F2. Okay. Next ray we will make going through the optical center and it will pass like this. Right. Now what we can see that these two rays, they are actually diverging from each other. In all other cases they seem to be converging on a point, but in this case they seem to be diverging and it looks like they are coming from a point behind. So we can actually trace these points at the back and this is where they seem to converge. Okay, we get an image on the right hand side of the lens. Now this kind of image is not going to be a real image. Okay, this is a virtual image and you can see the size has increased quite a bit. Okay, there is a large increase in the size, so it is a highly magnified image. So remember, if object is placed between optical center and the F1, we get a virtual image towards the right hand side of the lens. The image is erect in this case and it is highly magnified. Here is the diagram from the textbook. So I hope the image formation was understood. Now of course this topic is a little confusing if we are watching it for the first time. but I assure you, if you practice making them, these diagrams will not be very difficult. Okay, so that is the task I am giving for you today. Your task for today is only to make all the ray diagrams for the convex lens. Okay, make the ray diagrams, understand how the image is formed. Okay, learn to see the difference between a real image and a virtual image. Okay, now here is the table where all the relations you can understand. Okay, for the images that are formed by convex lenses. Okay, in the next class we will talk about image formation by concave lenses. Okay, but for today this is the task. I hope that you have understood. If you have any queries, please don't forget to send me. Okay, and I'll see you in the next class. Thank you.